right. So, section 1.1, so we are starting the new unit on parent graphs. We'll be starting with quadratics and parabolas. So we are starting with some of the basics, multiplying out and factoring. So first off, a monomial, so a single term, that would be the 2x by a binomial, x plus 3. So multiplying that out, this uses the distributive property. Some of you used the box for that in your algebra class, some of you didn't. Whatever you're comfortable with is fine with me. I don't need you to use the box. I don't require it. It's just whatever works best for you. 2x times x gives us 2x squared. And 2x times 3 gives us 6x. So this is 2x squared plus 6x. And I'm going to do a little squiggly line there so that doesn't get confused because it got too mushed up there. So the result of this multiplication is called a partial quadratic because we have an x squared and we have an x, but we do not have the constant term, so the single number by itself. So that makes this one a partial quadratic. Factoring partial quadratic is the opposite of multiplication, or the opposite of distribution. So basically we are undistributing when we factor if we have a greatest common factor. So what we're looking for is something, the biggest number and set of variables that we can divide out of both of these terms, the 10x squared and the 4x. So can anybody tell me what in terms of the numbers, 10 and 4, what's my greatest common factor? 2. Both of those are divisible by 2. So I'm going to put that 2 out in front. What about the x's? How many x's can I divide out of that? Not 3. There are 3 total. What's the most in any term? 1. So the lowest number of x's I have is 1, just that 4x. So I can only take 1x out of everything. So basically what I'm doing here is I'm taking 2x out of both of those, and I'm putting it out in front. So that's that undistribution. So 10 divided by 2 is 5, and x squared divided by x, if I have 2 on the top and 1 on the bottom, one set divides out, and I'm left with x. So those 2 x's divide out, and it looks like I crossed out the 2, but I didn't. And then 4 divided by 2 is 2. So that is my factored form. And once again, if I want to use the box, I start with the 10x squared and the 4x. I take a 2x out over here to multiply. To get 10x squared, I have to multiply 2x by 5x. To get 4x, I have to multiply 2x by 2. Same process, different methods of doing it. If you want to use the box, use the box. If you don't, don't. Any questions on multiplying two binomials? Again, there are 2 methods. One is the FOIL method. And that one says that you multiply the first terms, that's your f, and that's x times x, so x squared. Your outside terms, that's the o, so x times negative 7. Make sure you watch out for your negatives on these kind of problems, so negative 7x. Inside terms, that's your I in FOIL, so 3x plus 3x. And your last terms, 3 times negative 7, so negative 21. And that's your last. So first, outside, inside, last. That's what FOIL is referring to. Combine your like terms. So you have x squared minus 4x minus 21. That is one method of doing it. The other one is using the box. Again, if you're more comfortable than the box, then by all means, use it. So you take your first part, x and 3, put it on one side. X minus 7, put it on the other. X times x is x squared. X times 3 is 3x. X times negative 7 is negative 7x. And 3 times negative 7 is negative 21. And then you combine your like terms, and you end up with the same quadratic. And that is called a quadratic trinomial. Factoring those is the opposite of multiplication. This is usually done with a box and diamond. That's how most people learned it. But some people learned it I can't remember the word for it now. Anyway, some people learn it's the same method, but you're basically finding the two middle terms, and then you're using grouping to factor, and that's something I'm not going to teach you, but if that's your method of doing it, and you learned it from Mr. Denny, then keep using that, or you learned it from somebody else, that's fine too. But that's a lot of times where people learn that one. So, whatever method is more comfortable for you, use that method. So, factoring when your first term has an a, so this term right here would have 1, oh, you can't see where I wrote that, has a 1x squared. So this is your a, b, and c terms. So when a equals 1, it's pretty basic. You don't really actually need to go to this part, but I'll do the whole process for you anyway. You start with your first term in the lower left, last term in the upper right. Then you multiply those two terms for your top number. So 40x squared. Then you take your middle term, 13x, and you put it on the bottom. What you are looking for when you determine your side numbers are what two numbers multiply together to give you 40 and add together to give you 13. So, I'm going to show you the process. Some people know these numbers right off the bat, and some people have trouble figuring them out. So I'm going to show you the process that I use if you can't figure those out right away. So I factor the top number in pairs. So 1 times 40, 2 times 20, 3 doesn't have a whole number factor, 4 and 10, 5 and 8, 6 doesn't go in as a whole number, 7 doesn't, and then we're back to 8 and 5, and that's how we know we have all of our factors for 40. So what I'm looking for is what set of those adds up to 13. So that's 5 and 8. So 5x and 8x. Put those in the remaining boxes. It doesn't matter which boxes you put them in. And that's when you factor out. So your greatest common factor between x squared and 8x is just x. Same thing over here. We have the x times x equals x squared. X times 8 is going to give you 8x. And x times 5 is going to give you 5x. Anybody have any questions on part A? Okay. Questions there? Yeah.
I don't understand where the negative 4 came from.
So this right here?
Yes.
So when I factored out the 3x from these two, I have to figure out what I'm going to multiply 3x by to get negative 12x. So negative 12x divided by 3x is 4.
But wouldn't it be the negative 12x and the 8 for that?
For this one?
Yes.
Well, if you can look at it that way and take your greatest common factor from this row. So the biggest number that you can divide out of both 8 and negative 12 is 4.
Okay.
So that's another way to look at it too.
It just confused me.
Is it more clear? Any other questions? Okay. Finally, multiplying binomials, this is a particular one. No backside, that's what I thought. Okay. Alright, so some of you might have noticed, if we multiply these out, I'll do one with the FOIL method and one with the box. So I have x squared, 4x, negative 4x, and negative 16. When I combine my like terms, what happens with those? They add out. Some people say they cancel out. The only thing I don't like about canceling out is that they really add out to 0, and that's why they disappear. But a lot of times people have a tendency to say things cancel out, and they forget that sometimes the 0 needs to stay there. Not in this particular case, but sometimes it does. So just keep that in mind. But yes, we don't have them there anymore. Negative 4x plus 4x is 0. So we're left with x squared minus 16. On the other one, using the FOIL method, 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. 5 times 3x is positive 15x. And 5 times negative 5 is negative 25. Combine my like terms, which adds out to 0, 9x squared minus 25. So, what do you notice about your original binomials? So if you look at these two and these two, what do you notice about them? So your terms in them are exactly the same, x and 4 and x and 4, and you have one positive and one negative. Terms here, 3x and 5, 3x and 5, one is positive and one is negative. So when you have something like that, that causes your multiplied out quadratic to be what's called a difference of squares. So if you're looking at a term like this, if you're looking at an expression like this, and this has a perfect square root, and this has a perfect square root, and they are being subtracted, that is called a difference of squares. So if we look down at factoring those without using the box and diamond, you can use the box and diamond, but sometimes these numbers get pretty large and factoring all of them is a nightmare because the pair that you get is going to be the absolute last one that's going to work. So what you look at is, does 4x squared have a perfect square root? Yeah, it does. What is it? 2x. And does 9 have a perfect square root? 3. So this is going to be 2x plus 3 times 2x minus 3. This is where it's good to know this trick. If you have a fraction and you try to do this whole factoring stuff, it can be a little obnoxious. Does 1/9 x squared have a perfect square root? 1/3 x. And does 64 have a perfect square root? What is it? 8. So 1/3 x plus 8 times 1/3 x minus 8. So if you can recognize that pattern, you can always use your middle term as 0 and use the box and diamond, but it is much, much easier if you can see that pattern and recognize that it's a difference of squares. I would say, generally speaking, if you only have two terms, you want to check first if you can factor out a greatest common factor like we did in the first section, and then check and see if you have a difference of squares. So those are going to be your quickest ways to factor those two types. All right, that is it for the notes on section 1.